let's talk about logical equivalence, or if and only if. So the grammar is just that you put propositions on either side, and overall you get a proposition. And the meaning, the way to interpret it is phi, if, and only if psi. Or you can say phi is equivalent, not equal, equivalent to psi. And you can take it as meaning that the truth values of phi and psi are linked. So either they're both true or they're both false. So for this to hold, you need them to be both true or both false. They have to hold or fail to hold together. That is what makes the equivalence hold. So how do you prove and how do you use? Well, to use an equivalence is pretty easy. If you know phi is equivalent to psi, then from the truth of phi, you could deduce the truth of psi. And also from the truth of psi, you could deduce the truth of phi. So it's kind of like modus ponens, but is going both ways. That's how you use it. You can think of it as providing you with these two implications. Phi implies psi, and psi implies phi. So it's providing you with both of these to use. From phi, deduce psi, and also from psi, you may deduce phi. How to prove? So it's going to be harder to prove than an implication, because to prove it, you actually need to prove both of those implications that I wrote down. So to prove this, to prove the equivalence, you must prove two things. So your proof will split into two parts. Phi implies psi, and psi implies phi. Alright, so here's the template for proving, if you ever want to prove something if and only if something else. You assume you have two parts to the proof. First one where you assume phi and prove psi, then one where you assume psi and prove phi. So always see this split into two parts. Now that I have this symbol, I can clarify what was meant earlier when we said things like these two propositions are the same. So when we first introduced and, we said phi and psi, psi and phi are considered to be the same. Okay, does that mean they're the same string of marks? No, of course not. They're literally different markings. They look different. One is not a copy of the other. However, they hold or fail to hold together. So this is what's meant by saying they're the same. The truth of one implies the truth of the other, and vice versa. Another one is, I think we said, we treat the negation of phi as being the same as phi. And this is exactly what's meant by the same. And another one, actually, there was another situation where we wrote out the truth table for this, not phi and psi. And then we also wrote out the truth table for not phi or not psi. And we observed that in all four cases, in all four possibilities regarding the truth values of phi and psi, we get the same truth value for this as we get for this. So the truth values were linked. And so we said, oh, these are in some sense the same. And now we know the exact sense. It's that they are equivalent. Now that's not really a solid proof, because we haven't come up with a good explanation. There is an explanation, but we have not come up with a good explanation as to why truth tables count as proofs. And we'd prefer not to use truth tables as proofs, since our goal is to learn how to write mathematical arguments. So that truth table from earlier, I'm not going to take it to be a proof of this fact. In fact, we will go and try to write an argument proving this fact, and that will be one of the derived rules coming up very soon. You'll probably see it in Lecture 4. So it'll be a written argument of facts like this, using the methods for proving and using equivalences that were just described now.